Building an advanced modern RAG system is hard. Putting it on your premises is even harder. Making it scalable so that it can be used in an enterprise-grade environment is really hard. And then also having all the security so that it's air-gapped so you can be using it in a regulated industry is like turbo genius, mega hard. You need a whole team. Today, we're going to talk about how to do that in 10 lines of code in this episode of RAG Masters.
Hello, everybody, and welcome once again to RAG Masters, a show about Retrieval-Augmented Generation, maybe the only show about Retrieval-Augmented Generation. I'm Neil Katz, a 20-year tech entrepreneur. With me, as always, Daniel Warfield. How are you, sir?
I'm doing fabulously, and as always, I'm very excited. But this one's really special because we got a big one today, I think.
I actually think we do have a big one, like enterprise grade, enterprise scale. Big. Today we are talking about something that's, I think, actually really important, hasn't really been dealt with yet properly in the industry. We've seen so much work around RAG. We've seen so much work around cool demos of RAG, cool Twitter demos, and people have taken it farther than that. We just haven't seen a lot about enterprise grade RAG, how you do this in the environments that are regulated and have to be secure and have to scale, and how to do that without spending 9 months of development work and have a giant team. That's what we want to dig into today, because now it is finally possible, and we're going to show you how.
Yeah, let's get into it. So we got the slides. So
let's get into it. Let me bring them up.
Is it fair to say this is a bit of a release, right? We have this thing called GroundX On-Prem.
Indeed. We do have this thing called GroundX On-Prem. For those who haven't seen our prior episodes, so, Daniel and I both work for a company called EyeLevel.ai, and we sell APIs to build enterprise-grade RAG that's accurate and scalable and secure, and we make that really easy. But prior to today, we've been running that as a managed service, so you'd have to use it on our AWS managed cloud, which has been great for some of our customers thus far, like Dartmouth and Air France and some others, really, really great. But what they really wanted to do was not run any of this on our cloud. They actually wanted to sometimes run on their cloud or even on their premises, even air-gapped without any internet. And that's what we're actually launching with this episode. We're going to talk about all the amazing qualities of that. And Danny, maybe you could get us into how that works and why it's important.
Yeah, so it's GroundX On-Prem, right? So we have this feature-complete retrieval engine where you can upload complex documents and then use it to connect it to an AI model. But with On-Prem, so like being able to deploy it on your server, on a big computer you have in your office, whatever, you can completely remove that from the internet, which is really compelling in a lot of applications. If you're in healthcare, if you're in finance, if you're in government, you can't just send sensitive information to OpenAI for embedding. You can't just send it to Anthropic for, LLM completion. You need to keep it all within a contained system. That's so right. Today, we're going to show you how to make a contained system that does, advanced cutting edge RAG and be able to deploy it in an environment that you can completely control. There's no outgoing or ingoing information. Today, we're going to be setting up on AWS, but you can imagine it's Kubernetes based under the hood for those who are technically inclined. So you can imagine this setup in basically any cloud environment or any server that has Kubernetes set up.
Yeah, you could bring this in-house. This does not have to be on the cloud. And in fact, we've seen a lot of clients really ask for specifically disconnect from the internet. We saw an RFP from the Department of Defense just a few weeks ago, and literally the first requirement for doing this RAG was air-gapped on-premises. Like if you're crazy if you think our data is going to your AI. That's not happening. You want to talk about your AI and the interesting things you guys can do, that's going to come to our data. And that sits in this building, and this building is locked, and no one's allowed in unless we allow them in, and the data ain't coming in. And that's a significant part of the real economy. Telecom, healthcare, as you said, government, military, banking. You kind of forget in the age of cloud just how much stuff, the most important stuff sometimes in the world, doesn't have an internet connection because you need it to really be secure.
Exactly. And we're going to get in there and deploy an advanced cutting edge system in essentially 3 lines of code. So I have this slide. It's, so what we're really officially, releasing is the beta version of the free version of GroundX, but on-prem. But I think you'll be really excited in terms of its use. So anyone following along at home that has a little bit of AWS experience, we would love if you would, read the documentation first, set this up yourself, and then see what happens. So it all really starts, you just clone a repo. It's an open source repo.
Yeah.
And this repo allows you to do 2 things. It allows you to use Terraform to set up your AWS environment. So it sets up a VPC within an availability zone that you specify, and all the nitty gritty stuff in terms of like EKS, load balancers, and all that jazz. So it sets up an environment, like a set of compute resources that you can then deploy GroundX to, which is this operator / setup. So basically with these 2 lines of code, one is set up your AWS so that it has Kubernetes set up and all that jazz, and then deploy the GroundX on-prem beta to that Kubernetes cluster. So it's 2 commands essentially.
And so this is using Helm operator, and you don't have to be a Kubernetes expert or engineer. We're actually, in this version of it on AWS, really setting up the Kubernetes environment cluster for you. Is that correct?
Yes, but also like if you are a Kubernetes wizard, you can essentially use this sort of open source implementation and then just do the Kubernetes part on whatever environment you want. So we're going to be deploying it on AWS, but if you have a server that's sitting right next to you and it has Kubernetes and you want to go ahead and deploy this Helm operator, then go for it.
Yeah, absolutely. And, one of the, I think, important things here is that, part of what we're doing here with the Kubernetes layer is really, managing GPU and CPU processes. So to make RAG work well, you really need a combination of GPUs and CPUs to run various parts of that pipeline. And to make that scale and to make it efficient, you need essentially software that can manage those problems for you under the hood. And that's a lot of what this big kind of upgrade for us is doing. We've always been doing that for ourselves, but now we allow you to do it without actually having to do that work.
Yeah, it's super exciting. I can't wait. I'm probably going to be using it. I think a lot of people. Let's just get into it. I think
let's just stop, Matt. Yeah, stop pitching it and just show. Let's run it.
It's super exciting. It's super cool. So, all right. So you have to have an AWS account to follow this tutorial. And also you need the AWS CLI. AWS has this thing called Cloud Shell, which is super useful. It allows you to do configuration, but we're going to be needing to install Terraform and kubectl, and Cloud Shell has like a 1 gigabyte storage limit. So it won't work. So you need to install AWS CLI on your local machine. And then on that local machine, you're going to need to install Terraform and kubectl. We're going to have, this is an early release, and we're going to be, continually sort of iterating on this over, the next couple of months. So these installation steps might change. Check the documentation, when you go to deploy this yourself, but that's the general setup, right? And then the first thing you want to do is clone the repo and go into it, right? So if you've used command line, git clone, get the repo, it's going to install it on your computer. And then CD means we're actually entering the repo in the command line. So we're like going into the folder that it ends up installing, right?
Okay.
And then there's really one configuration step. You don't have to do much here. If you're super in depth, you can configure all sorts of stuff if you want. Really, the only thing that's kind of a requirement is you're going to want to change the API key and the username and email and password within operator /env.tfvars. That will basically set the credentials that you need to access the system, which we provide a sample env.tfvars for both the AWS deployment on Terraform and also the Helm operator. But you're going to want to change those credentials so that you're not spooling up an instance and then anyone has access to it naturally, right?
Good point. Yeah, good detail.
Yeah. So once you do that, though, it's like 2 lines of code, right? So you have everything installed. You call environment AWS setup, and then you say, hey, have you properly configured it? And then you basically specify the availability zone for this. It's US East 2, and then you just say, hey, is everything set up? And then it just goes. It installs all sorts of stuff. It sets up EKS, it sets up a VPC, it sets up security groups, it sets up all this jazz. Then once all that stuff is set up, then you call operator/setup. And that basically takes all of the Docker containers that we have hosted on, a container repository, and deploys those into pods within the EKS cluster. And there's a bunch of stuff, right? So it deploys a bunch of stuff in here. There's databases. There are load balancing systems. We have a variety of microservices that are being deployed to pods, and then those have different compute resources based on the requirements. We talked a lot about this in the previous video, and Ben kind of mentioned it, but basically we did a bunch of work to make sure things were set up efficiently so that, for instance, models were set up on compute resources that had a lot of GPUs but not a lot of CPUs. And then other systems that needed a lot of CPU stuff but not a lot of GPU stuff are running on different compute resources, and then they can talk to each other effectively. So the whole idea is we have this entire complex pipeline within GroundX to understand your documents and be able to query against those documents and all that stuff. And we set up all the resources for you and then deploy it for you so that you can just basically just use it, essentially.
Yeah, I mean, the insight here came out of our trying to work with some competitor software. I don't know if I have to say who, but when we tried to scale up ingesting documents to just 100,000 pages, which frankly is not a huge amount in our universe. We have some clients doing millions of pages per RAG. The system literally broke because they hadn't really engineered the GPU processes to work on GPUs and the CPU processes to work on CPUs. And so we almost had to take the whole thing apart just to put it back together again and make it work properly. And that was, I think, an important experience for us because it gave us insight that, wait a second, there's the managing compute underneath your RAG is actually really important when you try to do this in your own cloud or on premises. You want that to be pretty seamless, or you're in for weeks of work, and it requires very specific engineering skills that's not the same as being a Python engineer.
Yeah, and that's a whole other angle to this thing. It's like I don't know. There are a lot of I'm a data scientist, right? And I know about Kubernetes to some extent, and full stack and AWS. But when you really get into the nitty gritty of this stuff, you need an entire team, and to have an entire team, you need DevOps, and you need a lot of money to pay them, like all sorts of stuff. So
MLOps and data ops and security engineer and Kubernetes experts and
MLOps and ops, whatever, right? You just need a ton of people and a ton of time. And if you have this requirement of, you need performant RAG, but you need it in a data secure environment, you can kind of skip a lot of that and just use this as a first step. Also, by the way, we have this sort of public version. We also vend a private version so that we kind of do more of a white glove approach. So sure. You don't want to do anything, but we're talking about the release beta, right? So you can deploy this beta version, and it's highly performant and scales very well without needing to hire 30 engineers.
That's right. So what's next? So by the way, that all installed pretty quickly. What's the actual install time?
Oh yeah. So the actual install time, it's on the order of a few hours.
Okay, so it's a couple of lines of code in the terminal, but you do have to set aside a few hours for this thing to unpack itself and get rolling.
Yeah, if you have a demo for an investor in an hour, you might want to maybe make a fake demo before you you probably don't want to think of this as a last minute thing naturally. But yeah, it's relatively fast, all things considered, right? It sets up the entire environment. And if you wake up in the morning, you do it, and then you can mess around with it that afternoon.
Right. So this video is kind of like a Martha Stewart cooking video. She's going to show you how to prep the ingredients, and then voila, she's going to pull a cake out of the oven.
Yeah.
But she had that cake in the oven before the show.
Yes, that is definitely true.
Fair enough. All right, what's next?
All right. That's the end of the slideshow. Let me go over here. So we did it. So those 2 lines of code that I showed you that deployed an entire, AWS environment. So we have a bunch of EC2 instances. Those are existing within EKS. They're, scaling and doing their own thing. They have, auto recovery, all that jazz. And what you end up at the end of the day, when you read through the documentation, is on this particular environment, you'll get a single public endpoint, right? So this is like basically, a URL kind of. And to actually use this, to actually do RAG, you can actually use our existing GroundX SDK. So you can, pip install the GroundX SDK, which, you would normally use if you were using GroundX as a managed service. But the only thing you really do is you point it to a different host and you give it the API key that you specified in the configuration. So that locks it down to be exclusive to you. And of course, I'm using Colab right now, so this is communicating over the internet. You can imagine this Colab existing within the same VPC as the GroundX on-prem sort of installation.
Yep.
One of my lights is messing up. I don't know if you can see that. But so you can imagine this sort of existing within the VPC, so then you don't have to be talking over the internet.
Right.
Kind of up to you, right? But here I'm just kind of doing a demo. So we set up GroundX. It's talking to our AWS sort of instance of GroundX.
Okay.
And I mean, we just use it, right? So we create something called a bucket. This is where you can store documents, right? And then what I'm doing is I'm uploading this file to that bucket. So I have this complex.
This is on our public documentation that people use for a managed service when they use our APIs that we're hosting. Really no different.
And I imagine there'll be a brief demo of how to use it end to end within the documentation for this specifically, right?
I just meant that really it's all the same commands. Nothing inside GroundX really changes other than where you're pointing it to.
Exactly. So
go ahead.
Yeah. So I create this bucket and I'm uploading a document to the bucket. And this is a complex document, right? It's a complex PDF that has all sorts of weird visual, spatial sort of things going on. I'm uploading it and I'm basically checking, hey, is it done uploading? And then when it's done uploading, when it says status complete, I can go ahead and search something. So I can search something, for instance, like what testing protocol should I follow if the package is shipping LTL? If we look at this document right here, let me just move this.
Riveting document. We like testing with this document a lot because it's complicated. I always joke that I can't believe I'm giving demos people with like a shipping transit process chart. And I go, wow, look at this. Folks are like, yeah, okay. Okay.
The actual content doesn't really matter. What really matters is the structure, right? So
it's a hard document to deal with.
You can imagine this is like, I don't know, some process diagram within your fintech company, or this is like a medical document that has like, if this happens, then do this. If this happens, do this. These types of flowcharts are really common. And what we're going to ask it is, what testing protocol should I follow if the package is shipping LTL? And does the item ship LTL from the fulfillment center? And then we have this arrow that says yes. And then it points to follow the ISTA 3B protocol. So at the end of the day, the entire RAG system is going to need to understand the spatial components of this diagram to answer this question effectively. So what I'm doing here is I'm asking GroundX, hey, can you retrieve the information that is necessary to answer this question? Yep. And when I uploaded this document to my bucket, I didn't just upload this PDF to the bucket. I actually uploaded it to GroundX. GroundX did a bunch of processes to understand this document spatially, visually, textually. It extracted figures and represented them as text. It did all sorts of stuff. So on GroundX, kind of latently, it's representing this document in a representation that is compatible with an LLM. So when I call GroundX search and I ask for this, it's not just returning a page or something. It's returning this LLM-ready data that describes various aspects within the document that might be relevant to this question. So then what I can do is I can install, you would probably want to do this beforehand, but I'm installing an open source model. This is Llama 3.2 3B Instruct, so a fairly small one. And I'm telling it, hey, we have this context from GroundX. Can you use this context to answer the question? and then, think about your answer. I have a little bit of prompt engineering in there. So I'm answering, sorry if I can scroll up, I'm answering this question. What testing protocol should I follow if the package is shipping LTL?
Okay.
And I'm using this context.
These
and
retrievals sent to the local language model.
And then I'm getting a response, and this is the response. And as you can see, based on the provided text excerpts, the testing protocol to follow is the ISTA3B protocol, which is exactly correct.
But
and this is really cool because this is something I've talked about a lot. When you're doing RAG, you're actually offloading a ton of the requirements of the language model. Like if you have like a difficult set of information to sort of understand, you need a big language model that can reason about stuff. But if you've created really, really, really good contextual information that really, really accurately answers a question, then you can use a fairly small language model to just copy the answer from the context. So that's one of the really cool things about using GroundX is if you're on-prem, you might think, oh, I can never have something performant if I'm not using one of these massive hosted language models.
Huge misconception. I agree with you.
Yeah, exactly. Like if you're using GroundX, you can probably get away with a much smaller language model than you think, saving money and also, making your security posture much better.
Yeah, and I often say, like, if there's a problem with your RAG, if you're getting hallucinations, it's probably not the language model, it's probably the RAG. It's the pipeline of getting the right information. Can you ingest the documents correctly? Can you turn complex human data into essentially language model ready data? Can you get the search right? And if you do those things, you are basically setting up your language model, whichever one it is, for success. And we find that really all the top models today, Llama, Mistral, obviously the bigger name brands that are closed source, but all the open source ones as well, do really, really well with RAG if the RAG is good. And that's what this is really about.
I completely agree. I think we're both very aligned on that. And I think this is really crazy exciting because like we've had Twitter demos for a long time, but I've been using GroundX for a long time, and it is insane how good it is at extracting complex information from complex documents. And I know from experience that a lot of industries that are regulated have these complex documents. So the ability to do this in a free and open source, secure way, I think is going to be a complete game changer. So I can't imagine the types of things that will come out of this being released. I think the next couple of months are going to be really, really interesting.
I agree with you. I share your enthusiasm, man. I think it's going to be great. So listen, that's really this demo today. We're pretty excited to get this in the market and see what you build with it, as Daniel says. And until then, thanks again for joining us in this episode of RAG Masters. We will do it again next week. Like and subscribe, as always, if you want to learn every week how to do new RAG techniques, advanced RAG techniques, and explore all the latest RAG technology out there. Thanks a lot, guys. We'll see you next time.